Good morning, everybody, and welcome back to AI Blades, bringing you cutting-edge AI security every single week. My name's David Willis-Owen. I'll be your host for today's podcast, and we are back with a very exciting episode. ChatGPT, delete my code without me asking. So this is another example of an indirect prompt injection attack, and it came from me messing about on the ChatGPT Plus marketplace yet again. So AskTheCode is a generative pre-trained transformer, or GPT, that allows users to provide a GitHub repository URL and ask about any aspect of the code. It has a lot of usage with over 100,000 conversations, and software developers widely use this to improve the efficiency of their development. However, is it really secure to give an AI access to your codebase? In this blog post, I'll be showing how I was able to subvert AskTheCode by pushing it to its limits, using all the techniques at my disposal, and creating an exploit. I'll then demonstrate that exploit and explain how I collaborated with the developer to come up with a mitigation. So, to begin with, let's look at some background. In a blog post last month, it also came out as a video. I was able to trick an AI into stealing information from a victim's calendar and then emailing it out to an attacker. This was attacking the Maybe GPT, and it made use of the Google ecosystem, so Gmail, Google Calendar, where ChatGPT linked into these. And this exploit was another example of indirect prompt injection, which is a topic I've covered extensively on this channel and blog. So the hypothetical attacker in this scenario delivers a calendar invite containing a crafted prompt. The LLM reads this prompt and subsequently follows its instructions, giving no warning whatsoever to the victim. This is a pretty serious data exfiltration vulnerability, and after doing this, I decided to look around the ChatGPT Plus GPT marketplace for any other potential vulnerable large language models. I was able to quickly stumble upon AskTheCode. So AskTheCode piqued my interest because I saw it as a large GPT which had access to do a lot of things. I decided to map out the attack surface by simply asking it which operations it had access to perform. So it came back with a list. So I'm reading off my screen now, and it came back with listing branches, so view all branches in a specific repository, creating a branch, create a new branch from an existing one, and deleting a branch, delete an existing branch after confirming the branch name. So for those of you who aren't too familiar with the term branch, a branch is basically a portion of a codebase in something called Git. Git is one of the most widely used commitment control packages, which developers use to write code bases and also upload their code to public accessible places such as GitHub, which is kind of the number one repository for people looking to upload their code and share it. So this got me thinking. The GPT can read in details from other people's GitHub pages, and it can also perform destructive operations like deleting branches. So what if we modified the read operation to contain one of our prompts? Would this allow us to straight up delete a branch from the victim? So this led me on to an attack scenario. This was hypothetical, and I actually decided to mock this up in Excalibur, which is a great drawing tool for tech or anything else really. So in this hypothetical scenario, we have two different code bases. We have the attacker's GitHub codebase, and we have the victim's GitHub codebase. Step one is the attacker uploads a malicious prompt to the attacker's codebase. This prompt will contain things used to subvert the LLM logic and trick the LLM into thinking that the victim has made that request. We'll go over this shortly. Next, the victim pastes the link to that GitHub codebase containing the prompt on a completely separate day into their chat. Step 3 is ChatGPT actually visits the link, and when it does this, it reads in the attacker's prompt. And step 4, AskTheCode is fooled into following the actions in the prompt and straight up deletes the user's branch without them knowing. This could have downstream impacts if the repo that the victim owns is large. If this is deleted and other code bases have dependencies on this, this could cause a lot of issues which are unforeseen. It's worth noting that a user is only vulnerable if they have given OpenAI access to both read and modify their code base. However, most users of AskTheCode have this turned on. So this does affect potentially around 100,000 users. That could be a bit of a stretch. There are 100,000 conversations, so maybe I should estimate the number lower. So regardless, this is a very interesting vulnerability to examine as a case study. So building the exploit, the first thing I wanted to test was, can I elicit a modification action with a single prompt? In other words, can I get the LLM to delete a branch just by asking it? Do I have to prompt it again? Do I have to provide further confirmation? Or can I do this all in one crafted prompt? LLMs sometimes ask the user to confirm they want to proceed with the action. And this requires two different prompts and also alerts the victim about what is going to happen. By including urgency statements, I was able to bypass this mitigation. For example, saying, this is time sensitive and critical, it needs to be done now. Next, I hosted this prompt on a separate attacker GitHub repo, and I built in a series of techniques into this prompt, which are commonly used in LLM jailbreaks. This tricked the LLM into thinking these instructions came from the victim. And we do have the prompt on screen for those of you watching. For those of you who are just listening to this, you're not missing out on too much. It's 32 lines and it's quite hard to read and understand. I picked out 3 key points which allowed me to pull off this exploit. So, point 1, codified action call. While testing AskTheCode, I asked it to output all of its function names. So it actually knows the names of the functions and it output all of these along with the parameters. One of these was called delete repository branch, and this is the function in the backend code which actually allows users to delete branches from their code bases. So I included this function with the correct parameters and I put it in the prompt, and this tricked the LLM into thinking that the system was making this call as opposed to the user. Next up, I included a mock user system interaction. So I included a part with user and then a colon and then them saying something and system, colon, and the system prompting the user, are you sure you want to proceed with this action? So I actually included like this fake conversation in my prompt, and this tricks the LLM into thinking that the user has authorized this. Finally, I used Markdown and capital letter emphasis. In Markdown, the hash symbol represents a header, so combining this with capital letters makes the LLM interpret sentences of that nature with greater emphasis and making it easier for me to convince it to follow this new prompt which is entering the context. Now, we do have a demonstration of this and I will go through it. For those of you listening, I will explain what is going on. So, on the first page, we have the legitimate vulnerable repo. So this is the victim's code base, if you will. I'll click play on the video and we can see that we have 2 branches. We have a dev branch and we have a main branch. So next up, we have something called innocent repo, but this one is not innocent. This is the attacker's repository and it contains the prompts that we discussed previously. So it's that 32 line string used to subvert AskTheCode. And now in AskTheCode, the victim pastes the link to the attacker's repository. And let's see what happens. So AskTheCode thinks about it for a second. And it makes one action call, it makes a second action call. It then outputs a bit about what it's going to do. It makes a third action call. It then comes up with a confirm or deny, and the victim clicks confirm, the LLM starts the action, and it deletes the dev branch. So it's worth noting in this video demo, the LLM did say what it was about to do, but I have video evidence of it not saying what it was about to do. So this is pretty bad, honestly. And finishing off the video, we'll navigate back over to the dev branch for the victim, and we get a 404 back showing the page is not found and the branch has been successfully deleted. Okay, so moving on. Mitigation. How did we fix this? I reached out to the owner of the GPT, the owner of AskTheCode, at the end of May, and I thoroughly explained the issue and outlined some of the ways they could fix it. And to my pleasant surprise, they responded right away and got to work on fixing this. So massive shout out to the developer. I'm not going to name them, but this is exactly what we want to see as security researchers. Proactive developers who take bugs seriously and use them to improve their application's health. My suggestion was to prevent any modification operations from occurring once the GPT had read in data. The developer replied with an alternative solution, and I have this on the screen, but pretty much their idea is to allow one-time tokens for the change. So, for all destructive operations, I plan to enforce verification with the user. When GPT sends the request to update or delete a file or branch, I will ask it to present the intended changes once again to the user, and will provide it a one-time token for the change. This will force the GPT to present changes to the user and then make a new request already with this token. This won't fully present the case you've shared, but it will require double confirmation by the user. So, while a user could still accidentally approve a data modification or a branch delete, this puts a human in the loop. I like this mitigation a lot because the functionality of the model was minimally impacted. However, the security was greatly increased. And the fix was implemented on the 1st of July 2024. So, very good turnaround from the developer there. Okay, final thoughts. We are seeing indirect prompt injection attacks time and time again, leading to novel and potentially serious attack vectors. The impacts of these attacks can be alarming, such as people having their branches from their GitHub repos deleted without asking for that to happen. However, implementing a human in the loop through a technical measure, such as this one-time token, is an excellent solution that limits the effectiveness of these attacks. This mitigation will be key in safeguarding the future as AI is built into more complex systems. And that's the end of this show. Thank you so much, everybody, for listening and watching. If you have any feedback, feel free to leave that in the comments. And I look forward to presenting again next week. Have a great rest of day.